Hello, everyone. This course, we will introduce something about the BGP and the new dynamic routing protocol. And we will have one BGP basic principle in the RCNP course. Why we need this why we need this protocol? As we know in our network, if your network size will become very bigger and bigger. And for example, at the beginning, you only have 3 routers and only 20 segments. Maybe you use static route or maybe OSPF or ISIS routing protocol, it's enough. But if your network size to become over more than 20 routers or maybe there's 3 switchers, and also you need to do the communication with the other organization. Maybe it's lots of branches and located in different city. Maybe you have to do the communication with different internet with the ISP. In this scenario, the IGP protocol includes the OSPF and ISIS. It is very difficult to manage large scale networks. Because about these 2 protocols, we need to use the SPF algorithm to calculate the best path. If one link or maybe one segment is broken, or maybe you added a new segment, all the routers have to do the calculation again, and it will take a lot of resources. So in this scenario, if we want to do the communication between different autonomous systems, we suggest to use a new protocol, and this protocol belongs to the EGP, extrigator protocols. And about the EGP, we only have one protocol now. This one we call is BGP, Border Gateway Protocol. And about this EGP, we also can provide the loop-free routing information exchange between different AS. So we also have lots of mechanism to avoid loop, and also can reduce the resources to get the routing information. So this is a reason. And another reason why we use the BGP, that's because in the BGP, we have lots of attributes, so we can control the routing information to provide all the network can use the routing information. Maybe this also is the other advantage. And about the basic BGP, we have 3 topics. The first one, you have to know some basic concepts in the BGP. What is a BGP router, something like this. And the second one, if you know the basic concept of the BGP, and we'll have to know the principle, how to work about the BGP protocol, how to get the routing information. And the last one, we will provide some key configuration for the BGP if you want to deploy this protocol. And the first, let's see the basic concepts. The first concept is the AS, autonomous system. And you can think the AS belong to different finance or maybe belong to different organization. For example, maybe your headquarters, you can use one AS. If your network is very big, your headquarters is one AS, and the other branches, you can use the other AS. Or maybe different enterprise, they want to use different AS to do the communication. So if you deploy the BGP, you can make the whole network divided into different AS. Then in the same AS, you can use the same policy. The same policy means within the AS, one is AS, you can use OSPF, and the other AS, you can use ISIS, something like this. And how to distinguish different AS? We will give the AS number. And the number range is from 1 to 65535. And pay attention, We also have the private AS number, like the private IP address. Private AS number means different organizations, they can use the same AS number. But if you want to send out your routing information into the other range, you cannot use a private AS. Of course, we have lots of technology, for example, to replace the private AS to become public AS. Then you can send out the routing information. So the private AS number range is from 64 and 501 to 12 to 65, 535. This is a private AS number. And another is if you now divide a different AS, right? Maybe one enterprise uses AS 100 and another AS 200. They want to do communication with each other and how to exchange the routing information. As we know, if all the network devices don't have the routing information, we cannot forward the message because the layer 3 device will, according to your IP routing table, then encapsulates the message and then forward out. So if you want to do the communication with each other, the basic one is you must get the correct routing table. So one solution is between all the routers, you can choose to use IGP, Internal Gateway Protocol, like OSPF, like ISIS, and also maybe the other dynamic routing protocol. And one is the dynamic routing protocol, and another is you also can deploy the VPN established by an operator between different AS. So maybe you still can forward the message through the VPN, but between them, in the public network, maybe we don't know what's the detailed information. So this is the first solution. And also in them, maybe you can use the dynamic routing protocol, OSPF, to exchange the routing information first, right? Then you can deploy the VPN technology. And because different AS as the planning, different AS between different organizations. And if between them, you directly use the IGP to transmit the routing information, may pose the security risks. So this is a problem because in the IGP, like the OSPF, they will directly exchange the LSA information. And in the LSA, we can get the detail in your network, like what's the interface address, what's the mask, and what's the cost value, something like this. And the most important reason is if you calculate the LSA, it will take lots of resources. So this is a disadvantage. So as the IGP and the EGP planning, we suggest within the same AS, you can use IGP like OSPF, ISIS, right? But between different AS, we suggest to use BGP. Okay, we suggest to use BGP. So the BGP is an external routing protocol and usually used to transmit the routing information between different AS. So this is the application scenario. And the second one, BGP belongs to the path vector routing protocol, and it also is designed to prevent loops. Because in our course, we don't introduce a protocol about the RIP. RIP, maybe it's very possible to make a loop. Of course, this loop is different like the layer 2 loop. Finally, the message still can be discarded. And about the BGP, we have lots of attributes, and some attributes are used to avoid the loop. And BGP also belongs to the dynamic routing protocol, right? And how to work about the dynamic routing protocol. Between different routers, we must to exchange some routing information. And how to exchange? The router also will encapsulate the routing information in some special transport layer, and then the network layer finally to become bits and then sent to the other router. The same process of the BGP. BGP choose the TCP to encapsulate the message, and we will use the special port number, and the port number is 179. So in your network, if you do some filter policy, please pay attention about this port number. You must allow this 179 to pass through. So this is a basic one. And another one is BGP also can support classless interdomain routing and route aggregation. So maybe in your network, if you deploy the BGP, one router, the routing number may be over 10,000. So in this scenario, if you have a good IP address planning, you can use some route aggregation technology and to reduce the number of your router. So finally, when you forwarded the message out, you can make the process faster. So this also is a feature. And another reason at the beginning I talked with you, BGP, why we want to use this protocol? That's because the BGP have lots of attributes. And according to these attributes, we can do some policy to provide more load balance function in your network. And in this course, we also will explain some important feature. And another feature in the BGP, we only provide the incremental routing updates. That means, for example, at the beginning, we already get 10,000 routing from the BGP. And now, if you add 3 segments by the BGP, I only send these 3 segments to my neighbor. But about the OSPF, I will send all of them to my neighbor again. So we can reduce the bandwidth waste in our network. And the last feature is BGP can carry tens of thousands of routing entries, while IGP can only carry thousands. This is the main reason why in a bigger network, we want to choose a BGP to help us to transfer the routing information, because it is a good performance feature in the BGP. Okay. So now if we know some basic feature of the BGP, then let's say a typical application scenario. For example, if we have a large enterprise and we deploy multiple branches in different cities, and one branch belongs to one AS. And now if the headquarters and branches want to do communication with each other, we must provide the routing information, because we have lots of network devices in the whole enterprise. So we choose the protocol is BGP. And the BGP can run between one enterprise and one operator to transmit routing information between them. Like this topology, if we have 3 routers located in different branches, and between them we have the ISP to connect with each other, provides a physical link connection. Then between 3 routers, actually this is a logical router. Actually, maybe you have more than 3 routers, and we will establish the BGP pair. But pay attention, although these routers not directly connect with each other, because between them we still have the ISP to connect with each other, we still can establish the BGP peer relationship. So this also is a very, very big difference. with the IGP protocol. So if we establish the BGP pair successfully, then we can transmit the routing information. And if we calculate all the correct routing information, and finally, we can forward the message according to this routing information. So this is a very typical application scenario for the BGP protocols. And about this topic, we only explain some basic concept of the BGP. What is AS and what's the difference between IGP and EGP? And what's the advantage of the BGP? And we also explain some features. And here is one example to show you how to work about how to apply about the BGP. In the next part, we will explain the principle, how to establish BGP neighbor, how to transmit the routing information, and then in the routing information transmission, and if we have some loops, how to avoid the loop, something like this.